In lesson 9.1, we're going to talk about the Pythagorean theorem, and you probably have seen this already in Algebra 1. And on this page, if you wish, you could pause this and then take a look at the proof of the Pythagorean theorem. But suffice it to say that the way that most people talk about the Pythagorean theorem is they say that in a right triangle, a squared plus b squared equals c squared. And what I'd like to tell you is that actually is not the way I talk about it. I prefer to talk about that we have a leg squared plus a leg squared equal to a hypotenuse squared. And the reason I say that is just sometimes on the off chance, what if they did something that looked like this? I don't think they would ever do this, but what if they went A, B, and C? And if they did that, then of course the Pythagorean theorem wouldn't work, because in the triangle up above in blue you would actually have a squared equals b squared plus c squared. But it's always true that a leg squared plus a leg squared equals the hypotenuse squared in a right triangle. So I prefer to use that. On our second slide, when we want to use the Pythagorean theorem, it sometimes can come in handy. Like, for example, we see that we have a ladder here, and the question is, how high up a wall will a 10-foot ladder reach if the base is 6 feet away from that wall? And so, as I look at these different pieces, if you will, you might call this side on the bottom your A, and then of course off to the left here we have our B, and then the third side is the C. And knowing that from the way they describe the Pythagorean theorem of a squared plus b squared equals c squared, what we would have here is 6 squared plus b squared equals 10 squared. And then if we simplified, we would have 36 plus b squared equals 100. Of course, then we would subtract off 36 from both sides. And as we subtracted that off, you would have that your b squared is 64. At which time you would have to square root both sides, and you would find out that your b value would be equal to 8. Don't forget your labels. So in this case, I know that that's 8 feet. So the Pythagorean theorem can be useful in finding values when right triangles are involved. In this particular example on our third slide, we want to find the area of a wall that has a height of 9 feet and a diagonal of 41 feet. Now, in order to find the area of this wall, we know that areas of rectangles are base times height. Now, our problem here is that we have the height, but we don't have our base. Our base is the A in this case, and our height is the 9, but instead we have the diagonal of 41. So using the Pythagorean theorem, again, we know that a squared plus 9 squared equals 41 squared. Or in other words, I would have a squared plus 81 equals whatever 41 squared is. I think that's 1681. 40 times 40 is 1600, and then another, I think it's 1681. So then I'm going to subtract off 81 from both sides, and I end up with a squared being 1600. And if I square root to get just a, I get a is 40. Now this is not where our problem ends, of course, because the 40 is just the base. So if I want to find the area, going back up to the top, I know that I'm going to take the base, which is 40, times the height, which is 9, for a grand total of 360. And knowing that my label, if this stuff is in feet up from the story problem, I know that this would be in feet squared. The 360 is not being squared, just the label of feet. So again, the Pythagorean theorem helps us by being able to find one of the sides of the rectangle. the base in this case, so that we can find the area.